everything's. Morning.
Like today, everybody is relaxed.
Well, they are getting tired.
Tired, yeah.
Yes, but anyway, I'll.
Rest for some more time.
Yes, so I'm just waiting. I'm just curious. You are working on Grace. So I'm just wondering where you are on the list, just to make. Oh yeah. So this your. No, I'll just. Well, you can write your email if you want. So I'm just curious. She is working on, Anil, she is working on Grace, on Maspalas, using the satellites Grace. That was, so I'm curious about where she get to. Well, I can, well, yes, you can do that with your own words. I was going to write Grace. So, thank you very much. Follows and climate various using. So you're using, but you told me you were using the satellite data, Grace. So maybe that's another one, okay. No, okay. So I was just, okay. Someone else then. Okay, yes. Well. Are we expecting more students or not? Ah. Okay. Okay. Okay, now we have to start. So now we are coming to the end, to my last lecture in this course, and I'm calling it the response of the cryosphere to climate change. Anyway, we have been looking into the cryosphere, the ice within the hydrological cycle, and other lectures have been talking about processes in the atmosphere and also in the ocean and also solar radiation. So all this is a system study of the Earth. There have been 2 lectures on the biosphere, but I have been talking about, and in the first lecture we discussed this picture. So what we did, we discussed, I gave an overview of the cryosphere and where we find snow and ice masses on the Earth, and there was some description of various types of ice masses, morphology of ice masses. Then we talked about the transformation of snow to ice, the distribution of temperature in the glaciers, and how we are classifying glaciers by describing the temperature, and how important temperature was for understanding the glaciers. We talked about the evaluating of the glacier surface mass balance, which is very important, how we can measure whether they are growing or receding or decreasing in volume and mass. And then there was another talk about the energy budget, what kind of energy is doing the ablation or the melting of the glacier. Then over to glacier motion, which is very important, of course, for understanding how these ice masses move. And then next, about the flow of water through the glaciers, and even how melt accumulated and then we talked yesterday how the ice masses on the Earth are giving us information about or keeping the records of past climate. And now we will end by looking into what is going on here on this, what is happening to the ice masses. And then, so let me just repeat from the first lecture, that the cryosphere contains various forms: seasonal snow, sea ice. I will tell you what is happening to the sea ice, lake ice, ice sheets and glaciers, say a lot about that, ice shelves, and a little bit about frozen ground. And you have, through this course, got improved the understanding, I'm sure, about how water can be changing from one phase to another, from the solid to the liquid, and also into the vapor. That is meteorology. The liquid one is hydrology, can also be glacier hydrology, and the solid one is the cryosphere. And how this is all related to climate, this change from one phase to another, and delivering of meltwater to rivers, how this affects sea level and life on Earth. So this is so we have been touching many subjects. But then to the changes, present-day changes, I told you that the largest ice mass on Earth is here in Antarctica. It's 13 million square kilometers. Then I'm talking about the land. And the second one on land is Greenland with almost 2 million. And then we have all the glaciers outside the polar regions, and they only cover 0.6 million. So they are much smaller, and among them are glaciers here in the Himalayas, in European Alps, and in Iceland and Alaska and so on. But in addition to that, we have sea ice here in the north, and it's variable from 12 during the midwinter, and during the summer it's reduced down to 3, and it's been reducing at a rapid rate in the last few years due to climate warming. Here in the south, we have a very large, almost 20 million square kilometers of sea ice also. So it is the largest single area of ice masses, but it's frozen seawater. So this is what we have, and I'm not going into or repeating anything about permafrost, but and the other components of the cryosphere. Now you can through the lectures. So this was repetition. Now we also talked about why it's important to study them and how do we do it. And it's important because they are valuable resources of water, both drinking water and for hydroelectric power, for irrigation and so on. And they are contributing to the rising sea level in the world. And they may cause hazards. There may be hazards in the cryosphere to travel, to avalanches, to icebergs, which are hit by boats sailing on the ocean, and by floods and so on. And they affect climate, so they have influence on the climate, and the climate has influence on them. So it's both ways. So and this has been mentioned several times. They contain records of past climate, and now when they are disappearing at high in the mountains at a very rapid rate, it's urgent to do something about collecting this information, and you might in the future work on that in some of the mountain glaciers here in the Himalayan region. And then they are very important for landscape and erosion and all kinds of landforms. But we didn't include that in the lectures here. That is more into geology, but they are moving. They are scraping the bedrock and they are producing sediments and they are delivered into the river. So it's not far away from, but it's a special glacial geology course if you want to go on that, looking into that. And they have shaped much of the landscape in the higher altitudes in the northern hemisphere. There isn't much land in the southern hemisphere, as you know, it's mainly ocean. And then, what is going on? Well, we are observing global warming. It's both in the atmosphere and in the ocean. They're both getting warmer. And here is a record, a temperature anomaly. You've seen this several times in the course, I'm sure. That it was, we had a cold period here it's often called the Little Ice Age here in the 19th century, but then it started to become warmer and warmer, and then declining a little bit here, and this was discussed as I heard that maybe Professor Bala was explaining this dip here, but anyway, now it is, and this was had to do with sulfur or pollution in the atmosphere, but now it's rising, and this is linked to increased greenhouse effects by those who are working on that. And what is then happening in response to this for the cryosphere? If we start with the most obvious expression of global warming, it is the melting of the ice cover in the Antarctic Ocean here. Here you can see a picture. This is Greenland, and this is the ice, sea ice in the North, in the Arctic Ocean. And this is the area covered in 1979. And this was at the end of the summer in both cases. And this is 2005, and you can see there is you can see open water all around. So after that, it was possible during the summer to sail all the way here north of Siberia and through the Barents. The gate here, named after Barents, and into the Pacific Ocean, and this made a shorter route over to China and Japan than going through the Suez Canal and through the Indian Ocean here that way. So there is a lot of discussion about the importance or the impact of global warming on shipping transport around the world. So the sea ice is decreasing like that. Here you can see the northern. This is Greenland, and this is the Arctic sea ice in the Arctic Ocean. In September, this is 1984. There is some ice here, sea ice. It's much less here in 12. You can see, and all this is open water. So both routes, the eastern route, which is there, and the western route, is now, well, they are now able to pass that with ships in the summertime. And the prediction is that within 50 years, this is now 2000, and this is the observation of the extent of the sea ice cover. And now we are here, 2010, and well, anyway, we are here now, and the prediction is that before the middle of of this century, 2050, there may not be any ice at the end of the summer in this part of the Arctic Ocean. And this will, of course, be of very great importance for the albedo, or the reflectivity of the entire globe, and have immense consequences for climate. It will freeze during the winter time, but only form a thin sea ice layer, which will then be melted again next spring. So this will entirely have a very great impact, and this has been mentioned, I'm sure, by several speakers here. And then, so this is the situation with everything covered with sea ice. This is September, open water around there. You see similar fluctuations in the sea ice content in the southern hemisphere or around Antarctica. In March, you have summer in that part of the world, and there is not much sea ice. But then in September, you have a large area covered with sea ice. And then we are observing sea level rise from the 19th or 100 or throughout the 20th, and that is observed. It's observed in harbors, but also by satellites nowadays. And this is by tide gauges and satellite altimetry data. So what is going on is that this part of this ice is getting smaller and smaller and flowing into the ocean and increasing the sea level. And you know that if all this melted, the sea level would rise by something like 60 meters or so. So that's not happening yet. But if we look now at the various parts of the world, and start with the largest ice mass on Earth, which is in Antarctica, then we can say about the eastern Antarctica, which is this part here, it doesn't, as far as we can see, lose much mass. It's close to equilibrium, and increased accumulation seems to be compensating for increased melting. If you get increased melting, you get humid air masses approaching eastern Antarctica. You may get more melting, but you will get more snowfall at the same time. But what is important for us is that the western part of Antarctica is behaving in a very different way, and it is losing, rapidly losing mass, as most ice fields in the world. And if this ice mass disappears, it will be equal to a sea level rise by 7 meters. It will. I was once, well, we discussed some time ago, sea level equivalent. It's how much sea level would rise if you melt a certain amount of ice. And what is most important here is that this part of the Antarctica might become unstable or unstable. And when you are reading the newspapers, you often hear about that the floating ice shelves, which are a continuation of the land masses which are on the land, that they are breaking off in large pieces, But this, the floating ice doesn't increase the sea level if melted. Yeah, we know that. But if they are broken off, that might reduce the friction for the land mass, and the land mass might find it easier to move towards the ocean, and that would and produce more ice shelves and so on and so on. And so that is the instability of this land-based ice shelf ice masses. So if you break off the ice shelves, the ice on land might be increasing, and well, the flow of it might be increasing towards the sea. No, it's a very, very difficult area to do some measurements. It seems to be in equilibrium, in balance. And so they are not measuring any change in the mass in this part of Antarctica. And so I'm not so familiar with the details. They may, so the balance is the accumulation minus the ablation. So what is so this is in balance. So they are saying that if any melting due to warming of the globe is taking place in this region, then it must be compensated by increased rainfall or snowfall. But it's very, very difficult to do mass balance measurements in the field. So what they are relying on is remote sensing. So they are just they don't see any changes in the surface. So they are wondering, is it possible that there is increased melting? If so, it's just compensated by increased. But the reason why they are asking the question whether is global warming, shouldn't that increase the melting also in this part of the world? However, it's very, very cold here, and the increase of 1 or 2 degrees doesn't really matter. So I think they are not observing. There isn't much melting either, so it's just an argument that nothing is going on, and does not tell you that there is no global warming. No. So that is the discussion, you see. But anyway, so nothing much is going on in East Antarctica. If we look at the Greenland ice sheet, it's the second largest ice mass on land-based ice mass, and a lot of studies there. And the conclusion is that this land mass might survive for centuries, even though it's getting warmer. But what is going on there is that it's melting at a faster and faster rate. And what they are observing is that meltwater is percolating down to the base, increasing the lubrication and causing water pressure to increase at the base, and therefore the sliding. So they have been observing that the outlet glaciers here from Greenland have been, as the flow has been increasing, and that is due to sliding, increased sliding. So the transport of land masses here is to the ocean is now at an increasing rate. And, and they are very new. I just heard after I came here that the rate of increase is steadily rising. And when I did this, I wrote that it's losing 250 gigatons per year. Gigaton is equal to cubic kilometers in volume. But now I was told, I was reading on an email from some colleagues that it's above 300 today. That is the latest number. So this, it's melting at a rapid rate. And this 200 is equal to, so the melting in Greenland is now rising the sea level by 0.6 or millimeters per year, and the latest news is that this is a little bit higher. But the question is it likely that at the end of the century that this will be considerably smaller than it is now? Most of the glaciologists working on this are saying that the sea level might rise altogether by 5 centimeters from towards the end of this century by contribution from Greenland. But then, if warming continues, it will be melting at a steeper and steeper rate, and in 1,000 years from now, it might be might almost disappear. Okay. If we look at the ice masses outside the polar regions, we find that they are all receding. Well, this is 0, and the color is from yellow over to red. And you can see that red means that it's about 1 meter per year thinning of the glacier on the average. We find that in New Zealand, here in the Andes Mountains, here in the Himalayas, in Iceland, also in Scandinavia, or no, in the Alps, and also here in the Alaska region. And there are only very few glaciers in the world where you can see some blue colors. This was 0. But when this was published some years ago, a few glaciers were gaining mass, one here in, and maybe one, something here in the Himalayan regions, but very few, most of them were losing mass. And now I can show you the results from Iceland, which I have been working on, that the total mass loss of glaciers in Iceland has been 1 point. Well, anyway, this is a loss in gigatons per year, and it's up to 10. No, there is something missing here. I think it's this. No. I'm sorry, I have lost the number. The number which should be here is about 10 plus minus 1.5. So you can see 10 is here, and it's losing just for Iceland, which is only one small part of the cryosphere. It's losing something like 10 gigatons or 10 cubic kilometers per year of ice. And since in the years from since 95 until now, it's been losing 150. But if you go back to the year 1900, it's been losing 475 gigatons. And what you often see cubic kilometers, but this is in a unit of mass of water, giga 10 to the 9th tons. And this is the sea level equilibrium contribution from Iceland. It's not so much, but if you add all this together from all the glaciers in the world, you get a considerable value. If we look at the Himalayan regions, here is a graph from a publication by Bolk and Anil Kulkarni and some others. And with the result, this is the 1840, and this is 2000, and well, this is present. And here they have plotted the retreat. That is indeed in the on the snout of the glacier. But you can see that they have been retreating, all of them. This is Central Himalaya, Eastern Himalaya, Central Himalaya, doing the same, doing the same, doing the same. Western Himalaya also doing the same, and so on. But when you come to Karakoram, they find the glaciers which are not retreating so much. So there are a few examples of that. So some glaciers in northwestern Karakoram have advanced. That was the conclusion. And the reason for that might be increased accumulation. The accumulation is coming with the westerly winds into this, and so that was the conclusion. There are estimates, this was a retreat, there are estimates about the total mass, this should be gigatons, in the Himalaya mountains. And in 2010, there was a publication suggesting that the loss altogether was 47 gigatons, plus minus 12 per year, over this period from 2003 to 2009. And this was based on subtracting surface maps of glaciers. But then came a publication in Science, if I remember, based on Gray's satellite, and their conclusion that it was not 47, it was only 4. And this was based on the Gray satellite, which is measuring the gravity variation. And so there has been a lot of discussion, and I'm not sure where it is, how it stands now. And maybe some of the others mentioned that and here. But it is a dilemma. Does the Grays give a reliable value of war, or are they right doing, suggesting that it's 10 times higher? Well, the interpretation of this may be very tricky. You may melt ice, and the water is still in the region, and therefore it's contributing to the gravity field. So, and I am not an expert, but there was someone in the group here who told me, there was a girl here, told me she was working on Grace. Oh, there you are. Okay, so you should tell us. What can you tell us about the latest? Are you okay? You can take over. Here is the microphone. Yes.
It was basically a correlation of the mass change pattern with the genetic pattern.
Yes.
So I found a gradual increased dependence on western disturbance on the accumulation pattern from west to east
Yes.
compared to the past, and also increase in the eastern for my study period. A small allowance increase, which actually doesn't collaborate with the precipitation pattern, so that is something else.
Yes.
That's what I got from my
So
analysis.
then you're talking about the glaciers in the Karakoram, or are you?
No, Karakoram, yeah, the Karakoram anomaly is there.
Yeah. Okay.
It is visible,
Yes.
but the source of Karakoram anomaly is outside Himalaya. It comes from Tunisia and
Okay, from the.
it is outside Himalaya. What is different is I found an increase in the eastern side.
Oh, in the over to the Chinese part, or
No, this northeast Arunachal and this Sikkim that area, Sikkim Bhutan that area,
okay.
northeast China.
So are you happy with GRACE? I mean, are you satisfied with GRACE as a method of estimating glacier changes? You have some confidence in GRACE.
Yes, I have.
Okay.
If you want region-wise values, going to seeing a single glacier and extrapolating will give you a very huge error loss.
Yes.
If you want a regional-wise value.
Yes.
But in GRACE, you get a direct regional estimate, so that sort of the extrapolation error is very much minimized in GRACE. Still, one issue is just mass bounds.
Yes.
Which needs to be a little more defined, just a little more, and maybe GRACE will be perfect.
Yes. So do you believe that, would you conclude that the real change in the mass balance here in the Himalayan mountains is closer to 4 than 47? Would you, are you on that?
What it was actually closer to 47.
Is it closer to 47? Okay.
But actually, it is, method dependent, and we don't have such large ground truth cover
No.
like for Himalaya.
Okay.
So, collaborating that with ground truth is
No,
very
okay.
difficult.
This is very exciting.
This is the area where there's a huge knowledge gap, and this area accept the latest paper.
Oh yes, and they are very stubborn. I talked to them, and they are very arrogant. I mean, I didn't believe anything they said. They were so arrogant. Okay. No, they just said everything else. We are right. Everyone else is wrong. That was the only discussion. Yes.
You extrapolate it to a region. So you go to a group of 10 and extrapolate it to the whole region. And in Himalaya, where there is the gradual change in the climatic pattern from the western syntaxis to the eastern syntaxis, extrapolating will give you a bigger error than what is there in GRACE.
Yes. Okay. Well.
GRACE, I don't think it's perfect, but it could be nearer to reality than field study.
Okay. Have you, can you give me some new publications on this, or I mean reference to publications?
The newest is lately is 2007. This is the newest one.
Yes. So there's nothing.
Next to be mine also.
Okay. So when are you doing a master on this, or a PhD? Or?
Yeah, it is a part of my
Thesis, yes.
part
So I'm waiting for your thesis. Okay. Okay, this was interesting. Now we have some more insight into this. We will go on now looking into Greenland ice mass, the ice sheet. The contribution from the land well, we can collect together information. If we look at the reports from the IPCC report, And you can see this graph, which is showing you the change in the mass of these, and it's a cumulative curve. So here we have on top glaciers outside the polar regions. They are so far the greatest contributor to sea level rise. And altogether, well, they have been contributing 0.76 millimeters per year. Number 2 is the Greenland ice sheet. It's been contributing at that rate, as you see here. It's less than half of what the others are doing. And in Antarctica, fortunately, nothing much is happening. And that is the lowest curve here, but it's close to Greenland. So, but what I was telling you is that Greenland is now speeding up, so it's really starting to contribute at an increased rate. And you know that the glaciers outside the polar regions, they have a very limited capacity to contribute to sea level rising, because they may have disappeared in 200 years or something like that. And, and then we are left with contribution from Greenland and Antarctica. And then in addition to that, we have global warming also in the ocean. And it's not only in the atmosphere. And then, so the ocean are getting warmer and warmer, and the contribution from expansion is 1.10. So it's the largest single contribution. But when you, okay, and there is some, and total of this summary here is 2.8, almost 3 millimeters per year. And of the observed sea level rise, which is 3.2. But anyway, so we are able to explain most of this by observations, but there's something uncertain. Okay, and then we go to this. This is another way of showing the latest news about sea level rise is that it's rising 3.3 millimeters per year. And about half of it is the thermal expansion of the ocean. But then again, the latest news are, maybe not shown on this one, but the brand new is that the glacier contribution is now taking over and doing more than half of it. So anyway, glaciers outside the polar regions are contributing most. That's this red part of the cake. Number 2 is Greenland with this. Antarctica number 3. And then there are still some uncertainties. And you know that if all the glaciers outside polar regions were melted, the total sea level rise would could only be half a meter. Greenland might do 7.7 meters, Antarctica 60, and we shouldn't worry so much about all that. But the western part is most likely to melt, and that is 7 meters contribution, so it's similar to Greenland. And this is what is going on. Let's continue here. So this, and what is going on now is that the Antarctic and Greenland ice masses are reacting faster every year. And And okay, but the glaciers in the mountains all around the world are still contributing most to this. And we often say that they may be seen as an alarm bell to us about what is like, starting to happen in the climate system or in the cryosphere. So we often say they are like the canary birds in the coal mines. You know, all this. That in earlier years they brought canary birds into the coal mines, and when they died, it was time to run or to the surface again. And this is the sea level rise, 20 centimeters over the last century, and the predictions for the future depend on which scenario you are choosing and it is variable from, well, the predictions are something like, half a meter up to even almost 1 meter and maybe more. But I haven't seen any suggestion of more than 2 meters. But this is also discussed in the IPCC report. And here is indeed the latest report from them. They are considering, this is the sea level rise, first the observed one, and then the predictions for the future for several scenarios. And here are the scenarios. They are called various names. A1B is this one, and so on. This one is giving them the highest estimate, and it is called RCP85. But anyway, so this is the prediction for the, this is roughly about 2 degrees warming, this one, towards the end of the century. And then the prediction in sea level rise might be something like around half a meter. But if we take this one, which is, well, it's 4, 6, 7 degrees, I don't remember exactly. And it's not only temperature, it's a little bit more complicated. But let's just refer to temperature. Then we are expecting more. And if you look into the colors here in the columns, the contribution is divided between, but you have to read that from with your glasses and from the slide. So the total value is here, and it's made up of several contributions: thermal expansion, glaciers, Greenland, Antarctica, and so on and so on. So this is the latest report from IPCC. Was published recently, in 2013, almost 2 years ago. But there are still many gaps in the knowledge. First, I can mention that we need to know more about glacier volume. How much is the volume of ice is there in the mountains? We need to more about the mass balance changes. Well, as here in Himalaya, we don't know enough about that. And we need to know more about the response of various mass types to climate. Some glaciers, like, well, let's see, Eastern Antarctica is not responding so much. Western Antarctica is responding in a different way. So all this, you need more knowledge and more research. And then you need to know how the mass loss increases and spread towards north. When it becomes warmer, the melting is increasing at more and more or higher levels in the mountains and further north and in the northern hemisphere, and you need observations about that. You need further information about a feedback, what we call, and I heard that Professor Bala was talking a lot about feedbacks, they are positive or negative. And here we have the albedo feedback. And how will that affect the process when you are, well, as I said, when you are reducing the ice cover in the Arctic Ocean, you are reducing the albedo over huge areas, and how does that affect the climate system? We have also all kinds of thresholds. If you are passing a certain limit, you're just falling down. You reach a certain state, and then a sudden abrupt change takes place, and it's irreversible. I mean, if you walk over this and you fall down, it's irreversible. You're not climbing up again. And then there are dynamic processes in the stability of the ice masses. One of the most discussed one is the lubrication at the base. How does that increase the flow? We have also problems in the ice-ocean interaction, the warming of the ice. We get increased calving, increased movement of ice from land into the ocean at a higher speed, and this ice-ocean interaction is a very hot topic in glaciology now. And I can tell you that the IPCC report is a very cautious report. They want to be on the safe side when they are concluding. They are even voting on this, and if anyone is against, they rewrite the text. And so this is a compromise, and that's okay, but you need to know. They never say that something is a fact. They say extremely likely. And when people are reading this, they are surprised that there's nothing certain. They just say likely, very likely, and extremely likely. And why this reservation? Why 2 plus 2 is 4, not 2 plus 2 is likely to be 4. So it sounds like it's very strange. It's politics and not so much, not entirely science. So we can expect from the cryosphere surprises. They are to be expected in the future. So we need observations. We are always observing something which is surprising. We know a lot, but not everything. So then I will just conclude by saying that the melting of the glacier masses are one of the clearest signals of global warming. Sea ice is diminishing rapidly in the northern hemisphere. We said that. Glaciers outside the polar regions are shrinking fast, and discharge is increasing in glacier-fed rivers. We have outburst floods, and they are more frequent, and will stay like that for some years until the glaciers are becoming very small, and many glaciers have already disappeared. There is a shortage of water expected in the mountain regions along many major rivers in India and China in the future. And the polar ice masses have really started. They are about starting now to decrease in volume. Greenland is, well, you will read more and more about that Greenland is melting at an increasing rate. The sea level rise at the present is 3.3 millimeters, and just over half of it is due to glacial melt. That is the latest news. It may rise by 1 meter at the end of the century. That's a cautious estimate. But this will cause coastal erosion, increased floods. Groundwater will be contaminated by saltwater, and the lowlands submerged. And this will have a huge consequence for life in general. Impact in hydrology, and you can read this yourself. We can divide the impact into hydrological impact, the impacts on society and regional planning and geoengineering. You can look at the ecosystems and the oceans, but let's read some of this. The seasonal runoff will change. You can't rely on spring, on glacial water anymore if the glaciers have disappeared. There will be impact on glacier outburst floods. It will affect sediment transport. It will affect supply of drinking water, affect irrigation. There will be droughts in some parts of the world, and it will affect the development and the social development, and people have to adapt to new conditions. Maybe they can. It's very expensive anyway to be, if you have to adapt to something which costs a lot. It will affect engineering and transport and designs of roads, bridges, and power plants. It will affect the tourism, the mountain recreation, which is now a catastrophe in the European Alps. There's no snow anymore. It affects food production, and you may expect reduced agricultural output. It will affect public health. Diseases will be linked to this, and political conflicts, wars about water, not only about oil, but also about water. The ecosystems will be affected, will have effect on animal, birds, fish habitats, plants, also extinction of many organisms that are adapted to a certain habitat, and if the habitat is changing, they simply cannot adapt to it. We may be more clever to adapt, but it's in the nature it will take a long time to adapt, and you may expect extinction of species. In the ocean, you observe sea level rise and coastal erosion. You may also expect an alteration of the ocean current, the thermohaline circulation, which is the heat pump transporting heat around in the ocean, and Professor Pala told you about that. And you may expect long-term albedo changes and climate feedback. So this is something we have mentioned and touched upon. And then I will just say that this is a problem facing humanity, and it's impossible for single nations to deal with this, so it requires international studies in the cryosphere. And I hope you can, in the future, contribute to that. There is a large need for you. Okay. So thank you for the course. Okay, so now we have only 15 minutes break for the next talk, which is about the opportunities for you in India. Yeah. Okay.
so that we can move, because uh, now we are come almost last session of this training course, and after this there will be a concluding session by noon. And so before that, I thought it's very important to visit Dr. Sanjay Rao, who is the advisor in Department of Science and Technology in Netherlands, to come here and talk to you on glaciological research opportunity in the DST and Government of India. Because many of you have just started your career or you are about to start career. And idea of this program is to attract such people to come in the field of glaciology. But the selection of career or choices of career will not only depend upon how excited you are to do the science, but also depends upon what opportunities are available to you. So I hope last 9 days we have tried to excite you to do the glaciological science, and this lecture will tell you where to look for opportunity and fulfill your excitement and better career options. So there's no person other than Sanjay Rao in this country to provide you that information, essentially because he is a member secretary of Project and Advisory Committee on Glaciology at DST, and he is the man behind all funding given to all projects in which some of you are working. As well as under his leadership, new programs for glaciology are normally defined. Then he encourages new faculty members from different academic institutions to come together and build a larger program. So it is his contribution which is very important in sustaining glaciological research in this country. He is a scientist by training and by nature. I say by nature, which is very important because during the meetings, he rarely dwells too much on financial and other parts, but he wants to convince himself that this project is worth doing scientifically. So he has done his master's and PhD from Andhra University, if I'm correct. And then long back, maybe 35 years back, he joined DST and he rose the various hierarchies, and today he's advisor, which is the highest post one can attain in Department of Science and Technology. And he is, above all, very nice person, and he is a thorough. That means once decisions are there, taken, money will quickly move from Delhi to the various places. So he will ensure that. So he is an asset to our program. Therefore, I request him to give his thought on glaciological research opportunity, which in last few years, or 4 or 5 years, have significantly changed. So, Dr. Sanjay Rao, please.
So, at the outset, I would like to thank Dr. Kulkarni for inviting me and giving a nice introduction about me so that I have more responsibility to deliver. Before going into the real subject, I would like to invite all of you to take up challenging issues, not a routine subjects, what others are doing, I will do it. Because we are in a competitive world, unless you run extra mile, you are not being identified in the scientific community. With this small brief note, let us talk about next 40-45 minutes, what type of S&T and opportunities are available in general and with emphasis on glaciological research. So I talk about the reverse direction, the DST, Department of Science and Technology, then Science and Engineering Research Board, then to the glaciology. This is particularly, if anybody is traveling over the Himalayan region, so you can see the picture like this. It is very hard to reach. It is very difficult terrain to work, but there is no way. If you are a scientist, you have to at least visit once or twice in a year to see where you are working, how the ground reality are. Then you can sit in the lab and do your job and use the remote sensing tools and analyze. Unless you realize your ground realities, whatever you are doing, your assumptions may not be 100% accurate and true. Okay. So a bit about DST, which is a policy-making body in the country, and also looks into the strengthening the basic research in terms of the infrastructure capacity building as well as the human resource development, and also looks into the technology developmental programs, also linked to the societal, how the S&T can be useful to the society. And not only that, as the earlier speaker told, international cooperation is an essential ingredient for any upliftment or the scientific development. So we look into the international cooperation. And as a DST, there are many organizations, many sections within the DST. I'll give you a small brief. The INSPIRE is a component of the DST for the human resource development, which looks into from a 10th class passed student to the faculty and absorbing into the routine system, whether it is a government or non-government or whatever way. So I'll come a bit late, and I am dealing with the SERC and SERB. Formerly it is known as the Science Engineering Research Council. Now it is a board, and we have the autonomous institutions. So there are many autonomous institutions started by the eminent scientists by fashion, but that are being adopted by the DST to continue. To name few, even Agarkar Research Institute, Birbal Sahani Institute of Paleobotany, or Wadia Institute of Himalayan Glaciology, or Chitratinal Institute of Medical Sciences. So it indicates we don't have any barrier. Any subject started by eminent scientists, it will be taken further. But basic research is the backbone of these institutions. So the technology development is another area. Any new technology is developed, it should be commercialized and see that it will be reached to the people, society. So that aspect is also taken. And there are several missions like climate change mission, bamboo mission, or water mission, solar mission. There are several missions linking into the S&T aspects. As I told, international cooperation is a bilateral, multilateral, and going into the collaboration is an important activity. Not only we learn from others, we also give the training to the many outside people. So this department and science and society are the socio-economic sector, and there are several activities. So looking into the activities, how it is relevant to this program. Looking into the climate change, we have a climate change division, looks into the two major missions. Out of the 8 missions, 2 missions were given to the DST, and national mission on strategic knowledge for climate change. So it links up all other missions and provide guidance and input to the other missions wherever the statistically important scientific inputs are required from climate side, societal side, and security side. And the other mission is Himalayan ecosystem, where glaciers come as a part of the ecosystem. So they also look into the ecosystem modeling and the regional climate, how the climate change influences various sectors in the Himalayan region. So it is a bigger program, which deals around 550 crores of worth of the projects. They will deal with that. And this Himalayan glaciology program is not part of that, but it supports and collaborates and supplements their efforts. And the other activity, what you can look into, the Inspire Fellowship Program. So many of the, any Inspire Fellow or Inspire faculty? Yeah, so we have only 2 or 3 now, but in the last batch, we have about 8 people are the Inspire Fellows. Any student at the postgraduate level having a first rank, so those people are offered the fellowship. So fellowship is a JRF, whatever is existing. Now it is a 25,000 plus for the science graduates. If it is engineering, it is 28,000 plus. Plus means it is a HRA, wherever you are located, that is taken care. Now, the another attracting is faculty fellowship. Once you have completed your PhD, you've done excellently well, you have good publication record within the 3-4 years of the PhD program, you can compete for the faculty fellowship, which is equivalent to 80,000 per month, which is much better than the young scientist scheme, or a faculty equivalent to IISc and IIT with 3% annual increment for 5 years, and it is assured. Not only that, you will get a research grant of 7 lakh per year. They don't ask for which purpose you are using this. It is your disposal. Not only that, you can compete for the grants from other components. You can apply to glaciology program, no problem, you will get it, or the climate change program, or other ministries. So there is a wide opportunity is available to the people who perform at the doctorate level. So then coming to the SERB, Science Engineering Research Board, which is a national aspiration of the scientists, which is equivalent to National Science Foundation of the USA. But it will never match to them because of the grants or the projects they deal with. And it was constituted through Act of the Parliament. So in 2008, Act was approved by the Parliament, but it was implemented from 2011. So the vision is to accelerate the pace of discovery and delivery of science-led solutions for faster, sustainable, and inclusive growth. So if you look into that, if you look at discovery science, so whatever you are proposing, it should be of its kind. So it should lead to some new science, some discoveries. And delivery of science-led solutions, not necessarily the basic fundamental research. And if you say there is an application in the society, that also can be looked into, which is for a faster growth and sustainable and inclusive growth. So it is finally you are serving to the nation through your research and the society. And the objectives to meet that vision, we promote research in the newly emerging and frontline areas of science and engineering, including multidisciplinary. See, need not be I am a physical scientist or a chemical scientist, I don't interact with physics, I don't interact with the biologist. No, that days are gone. Now we have to interact, collaborate, and go further. And we also look into the research capability in the research areas of science and engineering, where we are giving the host institutions. So now from IITs and IISc, NISER, ISER, and we are penetrating into the college level. Wherever is the talent is there, so we have no barrier, we can support research. Earlier it was not the case. You have to look into the background of the scientist and how is lab and other things. Now we are able to provide necessary support even at a college level. But you should show that I am competent to get these grants. In a snapshot, the core research grant, scheme for young scientists, year 4, intensive research in high priority areas, empowerment and equity opportunities, or the R&D support. We have the several fellowships, J.C. Bose, Ramanujan, Distinguished Fellow, Prime Minister, Doctoral Fellows, and looking into the global linkages, Partnership for International Research Education is called the PIRE, Indo-US Grand Challenge, S.N. Bose Scholars, and GROW, GROW, Graduate Research Opportunities Worldwide, and international travel support, and professional bodies, seminars, symposia, and users. It looks like very simple, but to support these activities, at present, we spend considerable efforts to bring the talent into. So I'll try to explain one after the other so that you will appreciate where we are. See, to meet that, we look into the youth for attracting to science and researchers to support for investigator-centric research and travel supports, and the gender parity in science, we look into the women scientist scheme, and weaker segments, empowerment and excellence every year. So I'll come back to the one after the other, but it may not be a specific, but it will be inclusive when I talk about the different issues. So wherever the innovators are there, so we have to promote the innovation ecosystem, and we also look into the business incubation. So that is entrepreneurship, partnership, public-private partnership. I'll come to that also. The institutions, infrastructure strengthening, and regeneration of the research at the university level. Okay. Now, coming to the extramural research funding, individual-centric. This is given to the individual scientist on competitive basis, a competitive mode of funding, supports potential scientists for their research projects in areas of science and engineering. So any discipline, either physical sciences, mathematical sciences, chemical sciences, engineering sciences, and earth and atmospheric sciences. We have the 6 major disciplines. Within that, there are several sub-disciplines, so which are assisted by the program advisory committees, one on Himalayan glaciology, for which Dr. Kulkarni chairs, and I am the tile. So that is the activity we look into the potential scientists to identify and support. So given to manpower, equipments, consumables, conferences, and contingencies, where in each project we'll see that some human resources are generated and augmented. So basically, JRF and research associates are being supported under this. So whenever a project is given, we look for a good student to take up this. So these projects are normally for 3 years, and it can be extendable based upon the thing. So it looks into the 60 lakhs per year is the project cost, but for a simple thing. But it need not be a 60 lakhs for 3 years. If we are satisfied, and it can go up to 5 crores or beyond the 5 crores. So the thing is, as Dr. Kulkarni has mentioned, we have to scientifically and excited. Yes, we invest money, we will get output. So money is not the criteria. What science we are going to generate is the key. Okay, you are all young scientists. So we call it as the startup grants for young scientists up to 35 years of age. Now the fellowship is 55,000 rupees per month for 3 years under young scientist projects. So which costs about 40 lakhs. And you should not be employed anywhere. So this young scientist project will go. If you are employed, there also will get the startup grant, not the research fellowship for the self, but we can give an JRF into that, so that you can train another person. So how to get this? So as I told, you have to excel in your doctoral program. Whatever subject you are doing, do it sincerely, confidently, and at the end you say, this is my line of contribution added to the science. Then you are here, and whenever you apply within 3 to 6 months period, and we will give the result. So this is one opportunity. There is no limit for this. So because we look for the glaciology people, and whoever comes forward from the glaciology PhDs, we are willing to support. Okay. Even one time you say directly you may not get it sometimes, but an improvement is required, so don't hesitate to improve the quality and come back to us. There is no limit in number. Every year, as many as possible we can provide. So then comes to the intensification of research in high priority areas. So here, high priority areas. See, we, all the chairmen and members of the PACs met at Hyderabad, and we had a 2-day marathon meeting and identified some of the topics. Within that, you can say Earth's critical zone, glaciology and modeling, and climate change are the thrust areas to support. Climate change already taken care during the mission, climate change mission. But glaciology and modeling, any sort of modeling, it may be mathematical modeling, is a chemical modeling, or the atmospheric modeling, sediment modeling, and any modeling we'll look into as a priority area. If you really come up with a good proposal, and we can look into the up to 15 crores a single project. So that means you people have to grow up and compete for the best grants available. Okay. Then track-based research funding. Once you are taken as a scientist and you are doing the projects under the government funding, and the 2 or 3 projects you done excellently, and the peers has given you are doing excellently well, and the 3rd project or the 4th project you need not come for a presentation and defending. So because you are already satisfied 2-3 committees of experts, and that means your competence is evaluated at different levels, and automatically you will get a funding for 5 years. Okay. So upon satisfactory progress after 5 years, the project can be extended for another 5 years. So that means once in your young career, if you perform well, and your entire career you will be taken care. Rewards will be on its own way, it will come. So you are recognized as a scientist, a national fellow, academies. So we have the 4 academies. So any 2 academies at this moment, we have that criteria. You should have a fellow of at least 2 academies. Then in addition to your salary, you will get a 25,000 rupees per month as a personal fellowship, in addition to your regular salary, up to 68 years of age. It's not the thing, it's attracting. The attracting is 10 lakh per annum grant of research. So whatever way you want, you can spend. So we have more than 150 J.C. Bose fellows in the country. If you see the professor and J.C. Bose fellow, it is a recognition. It is a brand value. And PM postdoctoral fellow. This is another attracting scheme. And normally the government or any funding through the projects or the individual project, you will get 25,000 rupees per month. But this Prime Minister in the public partnership, so you will get double the fellowship. One fellowship is given by the DST and SCRB, and one fellowship equal grant will be given by the industry. So you are bound to work for the industrial problem, but at the same time, that industrial problem is converted into your PhD problem, so that at one stage you are working for the two. So you are getting the double the remuneration. So 50,000 plus HRA. So this is another opportunity if you excel. See, that's what we say, student gets double the scholarship, one from the board and one from the industrial sponsor for 4 years. So this gives the industry recognizes your work and automatically you will be taken care in a different way. Yeah, this is all national. Looking into the international opportunities. Overseas doctoral fellowship in select areas. Whenever we are going into a MOU with foreign universities, we are telling the glaciology is one important area, climate change is one area. If you are getting admission for this by any Indian scientist, please inform us so that we can support their research. But provided if the university will waive the tuition fees. Most of the universities' tuition fees exorbitant, $20,000, $25,000 like that. But now we have signed up many universities in UK and US and Germany, several places, even British Columbia, and the 5 fellowships a year for 5 years. At present, we are making. So please make use of it. You apply for any university, is tie up with the SCRB. That means in addition to their regular opportunities, the Science and Engineering Research Board also will provide you the thing. It comes around, $2,000 per month, 5 years. If it is a combined master's and PhD together, it is 5 years, and it will be given at a contingency allowance of some 60,000 rupees. It is not an amount, but the $2,000 per month assurance by the board is the thing which you can gain the knowledge from outside, and you have to come back and serve the nation. So that is the moral responsibility you have. You have the postdoctoral fellowship, so $3,000 per month. So this is for 1 year. So look into anywhere, so where you will get the admission, where the SCRB is having the collaboration or the MOU signed. So getting admission, you will get for 1 year, $3,000 per month. So we are looking into 150 fellowships in a year. I expect at least 3 or 4 postdoctorals in glaciological research. We have the S.N. Bose Scholars Program, Student Exchange Program, partnership with University of Wisconsin and Indo-US Scientific Forum. So this year also we have sent around 30 students to Wisconsin at a graduate level, so that 1 month to 3 months. So they will visit different universities in the US and come back. So during that period, they will choose who are the best people available, and those people will be given the further fellowship. So NSF Graduate Student Exchange Program, with NSF we have. So this is part of the GROW. So yeah. 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 Yeah, see, basically, wherever you look into their advertisement in the doctoral or postdoctoral research thing, so they will clearly indicate it is an SCRB collaboration. Whenever that collaboration is there, that is the understanding that they will waive the tuition fees or whatever the internal requirements, and externally from the board will provide $3,000 per month. Yes, at present. Yeah, at present. At present. Because we don't want to go into the small universities where there is no faculty, the facilities or the competency. See, basically we look into the top 100, 150 universities where the capacity building can be taken up. Yeah. It is a general MOU. It is a general MOU, and we have given the subjects. See, basically, whenever they come for the MOU signing, and we have the internal discussion, roundtable conference. So, in that conference, we raise the issue: what are the strengths you have, in which areas you can train our people. So, before that, we'll do some homework. If they have some good glaciologists working in that university, and that is the one of the core strength of that area, and we will straight away put up. Our area of support will be under glaciology. Basically, even I'll come down, so because in the Europe also 2 universities we have. The British Antarctic Survey is collaboration with some local universities. They told, when we told glaciology is our interest, then they told British the Antarctic Survey is our partner, so that we can make a provision in that. There is no problem. So people will be recruited to the university, but working with the British Antarctic Survey. So, sir, before going into any MOU, we will tie up with in a different ways and means, so that we should not be the loser, we should be the gainer. Yeah, any more clarifications? So basically, these all are going to be advertised in their own websites, and it is replicated in our SERB website. So you can go through that and apply according to the advertisements. Because it is a call, no? So 2 times in a year they will make a call, so you have to follow that. And Indo-US Research Fellowships, it is a US-based focused research, and here also we give a good amount thing. So it is 3 months to 1 year, and every year we support 25 to 30 students, and Earth and Atmospheric Science will get 3 slots, and so far we could get only 1 student applied for the working in glaciology. I could send her, the Aditi Badra from Northeast. So she was there for 3 months outside. So this gives the monthly stipend. So monthly stipend and return airfare, preparatory allowances, conference allowances. So normally it is for 1 year, but some people prefer a short visits. So that is also possible. So far 168 people being sent. So out of that, hydrology many people have gone, but not in the glacier research. So this is another program, SN Bose Scholars Program. It is through SERB and Indo-US Forum and the University of Wisconsin and Madison. So I told you, so this is not only from the Indian side, the students will go, like that American students also come to the India, and it is 1-to-1. So many of the American students are not coming earlier, but now this year we came to know that their competition is also increasing because of the ISERs and NISERs and the IITs are coming up very well, and the American scientists are also willing to come here. And again is the GROW program, and this is again lump sum amount to cover travel and other related costs, and SERB provides monthly living allowance in Indian rupees. So the people come into the Indian thing, so we will do that. Then empowerment and equity of opportunities. So there is a feeling that in the science competition, and some of our younger people are the some societally backward people are not getting into the opportunities. For that, we have a scheme. So once in a year, we will advertise, and the last year, we have about 350 grants awarded. So that means we are bringing back those people also into the S&T. And women scientist programs, we have the women scientist program in DST. At the same time, in SERB, we also recognize as women scientists. In the INSA, Young Scientist Awardees, any woman scientist is getting a INSA Young Scientist Award. So she will be given a fellowship. I think hear it or not. So this is only the Women Scholars Program. It's 55,000 rupees per month if you don't have the fellowship, and the project costs to around 40 lakhs. Otherwise, it is a 7 lakhs per year is a token grant given to the women scientists who are recognized as a INSA Young Scientists. And Partnership for International Research and Education, PIRE, and I think this is beyond this. So this educational programs, we are looking into the exchange at the student level. Then international travel support. This is one area where you can explore once in 3 years for all young scientists who are making a presentation outside the country, either poster or the oral presentation. We don't distinguish in between these two. So we'll provide the registration fees, travel cost. Also looking into the training programs and workshop, summer, winter school. For this, we need a specific recommendation from the guide saying that this training program is useful. Otherwise, seminar symposia for attending is not a problem. Just forward the application, money will go to the university or colleges. And the utilization of the scientific expertise of the retired thing. So if any scientist is retired, that is also we will look into. So in other words, we have the schemes from the young budding scientist at a level of a 10th class pass to the retired scientist. We don't want to waste any expertise at any level. And also some people want to come back to the India after their postdoctoral experience or spending some time in the universities abroad. And when they come back, the Ramanujan Fellowship and the salary is equivalent to 85,000 per month and a 7 lakh per year grant and for 5 years. So they can choose workplace in anywhere in India. So that within the 5 years they will be absorbed in the academic system or the research laboratories. So there is a comeback, reverse drain also we are looking into, the scientists can come back. And with this, we need a management. Management system is looking into more operational flexibility to project investigators, to rationalization of budget heads. So earlier we used to give everything every year, so this year you cannot spend more than this and this head is this. Now we are budging everything and putting into the one head, so there are a lot of flexibility. Even our research supervisors can support many things. And now online system project management, earlier we used to take at least 1 year to respond. Now within a 1 week period you will get a reply saying that your project is intact and we acknowledge that. So within 6 months period you know whether yes or no. All financial transactions done electronically. Now if you give the bank account details, so within 72 hours the money will be transferred. Earlier it used to take 3 months, 4 months. Like that, there are many issues. So, sir, this is the Cambridge University is having tie-up with the British, this Antarctic survey. And the Stanford University, several, so now the several universities coming forward. Once you know that they have the scheme, they are coming. Yeah, with that general introduction, my version of the glaciology. So glaciology research program is one of the challenging programs we handle in DST because there are many problems. There may be a snow cover, there is a glaciers, there is a snout position. Marking the snout position itself is an issue. There are boulders and debris. In addition to this, there is air pollution problems. So problems are many. But sitting in the air-conditioned room, we cannot talk about the glaciers without visiting the glaciers. Okay, so this is a complex subject. So take note of that whenever you are doing. And the real problems are, so this is also from this thing only. So this is dried up. So this was the biggest issue bothering of the nation. So glaciers are receding. Yes, it is receding. Then what? What to do? So it is a natural phenomena. So earlier we have the glaciers even up to the more inland areas. Now slowly it is receding. Can we preserve them? Can we alter them? So can we estimate properly what is the volume of the water, how much melt is coming up from the glaciers, how the rivers are handling, how the sediment is transporting to our rivers? Can this silt is making a bigger problems in the water transport and other issues? So there are many issues associated with that. And so I think previous speaker elaborate discussion on the global level, how it is looking into the problem. And we also is interested to look into the monsoon dynamics because we depend upon the monsoon. If you remember earlier, you told glaciers influence the climate, climate influence the glaciers. So in our case, the monsoon, so monsoon is going to be influenced in the hydrology sector, so hydropower sector, so there are many issues. So then source of water vapor. I think earlier one student has told the extratropical systems and the monsoon systems interacting, where it is interacting, every year is a different. So how the glaciers are given the input is different. So accumulation is a different. So every year the temperature patterns are different. Even though you say annually the temperature is the mean temperature remaining same or a 0.2 degrees either or, but the seasonal variability, interannual variability, seasonal variability, all influences the glaciers. But we don't have any information because we don't have much observational systems in the glaciated terrains. We depend upon the remote sensing. We depend upon some observatories sporadically available with army and other people. Otherwise, we don't have the observations, really what is happening in the glaciers. We need to develop that. And at the same time, different models are being developed elsewhere, whether we can import directly and work here. So to me, it's not. We have to calibrate and validate to our environment. For that, you need the field measurements. Without field measurements, you cannot do anything. So once you know the problems, so looking into the disciplines where you can work, whether you are an ecological scientist, eco-scientist, or you are a chemical scientist, or a hydrological scientist, an atmospheric scientist, or a earth scientist, or a geospatial science. Without GIS platform, so we cannot visualize the glaciers. See, without earth science, where is your debris, where is your moraines, and where is the altitude? So we cannot look into that. So the atmospheric forcing, atmospheric feedback, you need atmospheric sciences. The hydrological sciences, so because glaciers are melting and giving water, the inflow to the water, rivers, so hydrology is an important discipline. The chemical sciences, so how the aerosols is influencing, how the water coming from the glaciers are contaminated, and over the period of the travel from a glacier to the inland mouth, so how it is changing its chemical characteristics. Everything is important. Without chemistry, you cannot do. So whatever the discipline you are, whether it's a mathematician or a physician or a chemical or biological system or an information technology, or whoever you are, your background. So take glaciology as a one discipline where you can supplement and you will be an expert in the country. Because we have very few scientists working on glaciology, so you will be recognized, you will be rewarded. So recently we had a strategic plan how to do that. So we identified the measurements and observations and modeling is the key for the scientific development. So without measurements, without observations, and without modeling. So these three things should go hand in hand. To go hand in hand, we need hands. We need human resources. So this is the part of your training program is looking into the human resources development part. We also need field logistic and communication infrastructure. We are trying to do some sort of the field logistics, but the communication system is yet to be developed. And we don't have the full-fledged field logistics. One has to reach the glacier by trekking. The trekking may be a few days for some glaciers. So you have to acclimatize yourself to reach there. You cannot go from Bangalore to the glacier. So the height is around more than 4 kilometers altitude. So low oxygen. So there are many problems. How to solve that? We are looking into that logistic problem, but unless you people come forward, we say the number is more to work, so we cannot look for our own helicopters to drop you people in the field and pick up. So there are many issues involved in that, but we are trying to address. At the same time, national, regional, and international levels interaction. So in the HRD side, we are looking into, at the same time, field level, collaborations are going on with Switzerland, even Iceland, and France. There are several programs going on in the country so that those people come to our glaciers and train our people. So this is to tell in one snapshot, but if you look into each one, you can talk in one day. The science plan objectives is long-term observations and measurements. The physical, biogeochemical, hydrological, geological parameters is the Himalayan cryosphere in the different climate regions. Because if you go to the east to west, so the climate settings are entirely different. In the orientation is different. And the altitudinal things are different. So where some glaciers you can see from 4 kilometers altitude, some are above 5 kilometers altitude. Why? So we don't have any answers. Say south facing and north facing and east facing behave differently. We don't have any observational data or any understanding why it is. Even though simple physics says, so the radiation forcing is the important thing, but not necessarily the one. Maybe other factors are also influencing. Then finally, as I told, we cannot go day in and day out to the glaciers because the window is 3 to 4 months duration. So remaining period, what to do? So we have to develop modeling capabilities. So to look into the various processes at land, glacier, atmosphere, ocean interaction. So far, we don't have any studies to look into how the glacier-fed water rivers, giving the fresh water to the ocean, how this ocean circulation is getting influenced, how thermohaline circulation is influenced, even the thermal expansion of the rivers, the ocean can be controlled by the glacier meltwater, but we don't have any information. So there are many issues to look into. There are teleconnections, the feedback mechanisms, response to the climate change. So whatever area you look into, that is going to be the area where you are going to develop the expertise. So based on that only we can develop the policies. So basically the government of India is looking into evolving the policies, how we can. So we'll get parliament questions now and then to look into the what government of India is doing. The press is telling glaciers are receding, and the local people are getting the water scarcity because of the glaciers are melting, and what government of India is doing. Government of India alone cannot do anything. You all people have to collaborate and cooperate with us and do good science. So we are also looking into geoengineering aspects. So my intention in telling geoengineering is, okay, glaciers are melting. Can we stop? Can we reduce the acceleration of the receding of the glaciers? So that itself is a good contribution if you come up with some engineering technique. Okay. Broadly, we look into some thematic areas. So glacier observations, geochronological framework. So this is basically past climate change. So 20 million years back, what is the climate? 10 million years back, what is the climate? 1 kilo year back, what is the climate? And how we are today. That we will get only from the glaciers, glacier ice cores. So that is one thing we are looking into, chronological framework, modeling and sensitivity studies, movement and thermal characterization. So by definition, glacier moves. But each glacier is having its own response time, its own movement. Why? What critically influences? Which is the bottom topography or the climate forcing or the basal sliding, and that needs to be further looking into. Hydrology and sediment transport, where 20 years back we started the work, many rivers we have the data, but there is no uniform methodology to intercompare between the rivers. So that is the one issue we are facing. We have the database, but we don't have the standard operating procedures so that all make the same uniform measurements so that we can intercompare and understand. So ecology and societal applications. So basically the society where the living near to the glaciers are affecting, and ecology in the sense the tree line is going upward. So can we convert the glacier vacated regions into the fertile agricultural land? So this is one issue which is important for the society. And as you know, there are 9,500 glaciers as per the Geological Survey of India. We identified about 10 glaciers as a benchmark glaciers. But if you look into the number, 1,000 glaciers, one as a representative glacier we are monitoring. Is it sufficient to quantify? This is certainly not. We need more and more glaciers to be monitored continuously for the long-term measurements. Then only the models can be verified. Unless you people join hands in glaciological research, we cannot grow more than this type of benchmark glaciers. So my humble request is you join glaciology. Okay. So there are several projects we support. So from region and the topic wise, we look into those. To develop this, we also looking into start an institute, National Center for Himalayan Glaciology. We started Center for Glaciology with about 19 scientific manpower, but we are yet to convert into a national center. Hope it will come soon. I am hopeful it will come soon. And it looks into pursue, foster, and promote excellence in scientific research on glaciers for sustaining Himalayas. So this institute is expected to network all the Indian scientific organizations working on the glaciers and to do that. so that it could be a data depository and data exchange with other things. So it can be a response to the governmental policies. So recently we organized the training programs in the field itself. So this is the classroom training, and we have the two types of training programs. One with the Swiss government through JNU. There's a 3-level training program, whereas through the glaciology program, through Geological Survey of India, we organize a 5 to 6 weeks training program at Hamta Glacier. So we'll create logistic facilities in Hamta Glacier itself. So you people will be there for 20 days on the glacier. The faculty, the experts will come over there and explain each and every feature, how to measure, where to measure, and how to look into their snout or the stake measurements or whatnot. You see, everything will be shown and demonstrated on the glacier. That is Hamta Glacier. Whereas the JNU will take you to the Chota Shikri Glacier. So it is a hard time for the many people, but it is a fun also, because staying in a glacier, in a tent, cooking yourself and learning. So that is a good experience. And if you people have not gone for that, next year we are going to advertise for the 20 people. So be one of the participants in that. So there are many things. So even Switzerland, we are having Iceland. There are many programs. And we also developed a program on Gangotri Glacier. So Gangotri Glacier, we brought about 8 organizations together work on Gangotri Glacier. So it is the good work of Dr. Kulkarni as a chair, and we could bring different people to work on one glacier. Otherwise, everyone wants their nearest glacier. But thought this is the one of the glacier of the nationally important and religiously also an important glacier, which worldwide known, Gangotri Glacier. And there is a controversy, the Gangotri Glacier is going to melt by 2035, even though they have withdrawn that, but still the people have in the mind. So about 20 scientists now working on this particular glacier. After 3 years, you can get some good data set on this. So as I told, working in the glacier is a very hard task. So many of you people might not have visited the glacier. Please make it convenient to visit a glacier and work in the glacier. Then only you appreciate what are the glaciers and how they are. And from our side, in the projects, we are doing some sort of support. We'll give the hardship allowance. When you work there under low oxygen conditions and harsh environmental conditions, 500 rupees per day, a token compensation will provide. So many of the things you might have seen, say the debris cover or the pit measurements or the stake measurements and installing the automatic weather station. See, everything is a tough task. Okay, then outreach programs. So we also started developing the programs through brainstorming sessions. See, because we have to bring the people together and nurture the culture, work together. So we have the Gangotri Glacier, I told we have around 20 scientists working on that. Now glacier volume estimation, we had the last year in the IASC, now 4 projects were evolved, and we are looking more and more on the volume estimation. You see, 4 glaciers or the 4 small regions is not good enough to make an estimation of the entire glaciers. So we look forward, some more people join in this. And we have one unfinished agenda, ice coring in the Himalaya. Because we don't have expertise, we have to get expertise from outside. Bringing expertise from outside involves several strategic issues. So hope in next 2 years period, you can hear a coring is being taken in the glaciers, Himalayan glaciers. So far we don't have. We have one core. On the same day it was melted in the Himalayas and taken out. So there is a lot of mixing. We could not get any significant scientific thing. And last year we had a Himalayan conference. Some of the young people have joined there. More than 100 scientists participated. And December is not a good time. That was the conclusion we got. So next April, May period, we'll go for a national conference. And by that time, you people come up with some activity, some proposal, some research result, so that you can be a part in the national conference, so that you can know what is going on, what is happening in the other institutions, other colleagues are doing. And we are also extending assistance, not only the ITS program, special drive to send the people to some conferences. This January, about 20 young scientists participated in glaciology on the high mountain Asia. So any opportunity comes, so we are willing to send you people. You make a watch so that you can attend international conferences and gain information, knowledge, what is being done in the outside the world. And research publications come after some time, but you have to follow the latest trends, otherwise you are nowhere. And this is my last slide, and there are many issues. So looking into a third dimension of the selected glaciers, you see, we know this is the length of the glacier, this is the width of the glacier, but we don't know exactly what is the third dimension of the glacier. So for that, we need a geophysical survey, laser surveys, and many techniques has to be used. So the paleoclimate and ice core drilling is already mentioned. The chronometric mapping and glacial moraines, landforms, and other proxy indicators. Even we promoted some studies on dendroclimatology, tree rings, and other things. So there are many issues. So we also need to inventory, update the inventory. The biogeochemistry is one area we don't have much name, nothing. No work has been done. And one database development is an activity which is unfinished. So hope we'll do that. And the modeling and simulation activities are the core of the progress. So thank you very much.
Thank you very much, Sanjay Raoji. And by now you know that there are many opportunities available for you for glaciological research in India and where to look for. And I hope some of you will take up glaciology as a career. Since he has come all the way from Delhi and given this special talk on our request, so we appreciate that, and on the behalf of Divecha Center for Climate Change, the small token of appreciation, I would like to give him.
So I will be available until tomorrow lunchtime. If you have any questions, clarifications, I will try to address. Not necessarily clear your 100% doubts, but try to address. Thank you very much.
Okay. Everybody's here or? Hmm? Just check. Okay, it's wonderful. And now we have come to the final leg of this training program. And may I request Professor J. Srinivasan, Dr. Sanjay Rao, and Professor Helgi to come on the dais. So, last 10 days was a really wonderful journey for all of us, and I hope it was for you also. We try to cover as much as possible and make you aware of the different facets of glaciology and related subject, which we thought are important for you, for any student to know. So there may be some gaps in it, and you might have thought that something more could have been done. Therefore, we have provided you a feedback form. So I request you to fill that form, if it is not already filled, and give your frank opinion. And I hope you will, if you feel it is anonymous is the right thing to do, you are free to do it. It's no compulsion on you to write your name, but make sure that you give us feedback, because it will help next batch, which we are planning to have a training. So this particular training program is the idea started at Divecha Center around 4 years back, and we have first training on snow and remote sensing and climate change in collaboration with University of Sherbrooke in Canada. And last 3 years, we are having wonderful collaboration with University of Iceland. And I know it is difficult for Professor Helgi to travel all the way from Iceland, particularly during summertime, because Iceland is not a country where you want to live during summertime. But our academic calendar is such that we have to organize it in June, because most of the students who are doing masters and PhD, this is a vacation time for them. So we have to attract them or get them here. That means it doesn't have to clash with the academic calendar. So because of that, this is the time which he thought is appropriate. They have to leave Iceland during summertime and come here, and he's consistently coming. Last 3 years and spending almost 20 days with us, and that has not only benefited this training program, but many of our students who are working in glaciology, because his unique expertise on glacial dynamics are not there in India. So his contribution is really unique in developing glaciology in this country. My special thanks to him for coming. We all appreciate the contribution which made by him. And as a token of our appreciation, I would like to request Professor G. Srinivasan to give him a small token. You have already listened a lot from Thora, who is a professor at University of Iceland and the chair of Environmental and Engineering Sciences, if I am correct. She is highly accomplished professor in Iceland, published numerous books. And her couple of lectures has given a new direction to this training program. Particularly, many of you wants to work on issues related to permafrost. So some of her presentations were unique, and it was first time made in this training program. And she also joined Professor Helge, and both of them have come. It's wonderful to have them here, and we all have enjoyed their wonderful company. And above all, she's a very pleasant guest to have because she enjoys Indian food. So you can talk many things nicely together having Indian food. So I will also request Professor Jayasri Nivasan, so on the behalf of Divecha Center, to give her a small memento. This training program has different facets, and different people look in different way. And therefore, I would like to invite Professor Helge to give his reflection on the training program. Professor Helge, please.
Well, I will be short. I just want to thank all you students for a nice, really inspiring company and discussions, for your curiosity about what I've been talking about. Then I would also like to thank the Institute and the staff of the Institute, which some of whom I'm getting to know after 3 years quite well. So, and thank him for their hospitality. It's been a really nice day. I certainly hope that this introduction, which I was only able to give in 10 lectures and 3 practicals on the cryosphere science, was useful to you, the students. I know that you have various backgrounds, so you have been, some of you have been doing remote sensing, others even, well, geology or geoscience in general, some mathematics and so on and so on. But I want to tell you that there is a space for you all in cryospheric studies. And I can speak from my own experience, because when I was at your age, I had done some basic courses in mathematics, physics, and some geophysics. Then I became interested in atmospheric science, so I did some meteorology, and then solid earth geophysics, and a little bit of oceanography and so on, and hydrology. So I had, and there was nothing at that time which was called glaciology. But then, at your age, I decided to do some research projects on glaciers, and that's how I became a glaciologist. And nowadays I'm not looking at myself as a glaciologist, even though my background is geophysics. I have forgotten most of seismology or whatever it was I was learning in the beginning, but I'm still familiar with the processes in the ocean and in the atmosphere and so on. But I've been working in glaciology, and that's how we become glaciologists. My colleagues all around the world have background in physics, even nuclear physics and so on, and now they are glaciologists. So this is how it is done. And I hope this course, that you have found some of this of interest, which we have been talking about. And you already told me, some of you come and say, I'm interested in ice cores, I'm interested in well, several topics, I'm interested in ice, large ice sheets, and I have been trying to give you some contacts. And my email address is here, and I would really like to hear from you. And if you need further information about any contacts, we've been discussing here contacts with some colleagues in UK, in Norway, and so on, and the States, and I know a lot of them. So I could maybe guide you. And India needs more glaciologists, and as I have pointed out several times, this is not. This is a problem which requires international collaboration. Every nation has to be contributing somehow to glaciology, and you have to do it yourself here in the Himalayan mountains and the Ural Mountains. And then I would just wish you good luck and success in whatever you decide to work on. And I hope to see many of you in the future at international meetings, or maybe here in India again. So I really thank you.
Thank you, Professor Helge. And you know, this course was possible because it is sponsored by 3 major institutions. One is not institution, one is the Climate Research Fund and University of Iceland, Reykjavik. They have supported this training program, and the visit of Thora as well as Helge is possible because of general support provided from them, as well as some of you, if you choose to go to Iceland, that support will be also provided. So I would like to thank for them. But in addition to that, this training program is also partly supported by Department of Science and Technology, and of course Divecha Center for Climate Change. Without that, nothing is possible. But it's wonderful to have Dr. Sanjeeva Rao here from Department of Science and Technology. He's a busy man in Delhi because a lot of activities are happening there, but he decided to come here and gave one lecture to you and also participating in this concluding program. Therefore, thanks Dr. Sanjeeva Rao for visiting here and helping these young boys to fulfill their dream to become a leading glaciologist. But at the end, all these activities are possible because of support and the strength provided by Divecha Center. And the guiding force of Divecha Center is nothing but Professor J. Srinivasan, who helps all of us, and he has provided necessary leadership for this. And that is how this idea of training program started around 4 years back. So I would like to request him to give his thoughts on this training program. Professor Srinivasan.
Let me say that this idea of the training program was Professor Anil Kulkarni's great concern about training glaciologists in the country. So he has been the driving force behind this idea, and for the last 4 years, he has ensured that every year we conduct a training program. And this year, it has been the largest program that has been conducted. The number of participants is very large. And I can tell you that this is the first time I've seen such enthusiastic interaction and participate by students. So I'm really happy this time to see all of you take real interest and interact with all the speakers and in the tutorials. So we are very happy to see that the effort that Anil has put in to organize this training program is bearing fruit. And so I think the format he chose this year, I think, was the best, and I think we are learning from this experience. And as you pointed out, the kind of feedback you gave will help us to make it better next time. But you must remember that this program's unique feature is the two guest lecturers we have, Professor Helgi Björnsson and Professor Thora Ellen. Without their presence, we would not have the kind of expertise in glaciology that is needed to run the program. So let's thank them once more for this support. And of course, we are also very happy that DST has a major program in glaciology, through which they support this training program, as well as the visit of students to conferences and workshops. So that is another important thing for which we thank Sanjay Rao for this. Now, finally, we hope that many of people who are attending this training program will pursue a career in glaciology, and even if many of you may not, because each of you have slightly different interests, that whatever you learned here will become useful to you in your career. So we wish you all the best, and we hope you continue to interact with us through email and other ways. Thank you.
Thank you very much, Professor Srinivasan. So now we will move to the final stage where the distribution of certificates. Oh yes, sure. Anyone like to give feedback, please? Yeah, sure, please.
Hello. Thank you. I being from outside, not really outside, but Bhutan is Bhutan in India. From our Bhutanese angle, we consider Bhutan as a nationally, politically, and very close friend. Within the course of the past 9 days training, it was a really good experience for me, and then right now I just stand up here to verbally express my heartfelt gratitude to all the resourceful scientists for throwing a light on my ignorance over the understanding of Glacier. The knowledge and the skill experience regarding the glacier is very important in Bhutan. And Bhutan right now is developing, but still it is under least developed country. We always go for hunting the fund to do all the research activities. To build the capacity within our country, has become a primary task for the government, because our government cannot fund employees to send people to conduct this training. Right now, I am here because my travel fund is supported by ICIMOT. The core fund is from Foreign Ministry of Norway. And I'm really lucky that Dr. Anil accepted me and one of my friends. She's supposed to come here, but unfortunately, at last she couldn't make it. Still then, on behalf of her and myself, I want to thank you. And the skills and experiences and especially the theory and whatever I've learned from here, I will take to home, and then I will never forget. Instead, I will try to learn as much as possible. And then before, I was in dilemma whether to choose glaciology, or because my background is nowhere it is reflected in the spectrum of Glacier. I'm totally from electrical engineering background. Now it inspires me to take up that, not only to gain my personal thing, but to serve the royal government of Bhutan. Thank you.
Hello, I'm Ashim, and I belong from Northeast. And first of all, I'd like to thank for selecting me to participate in this program. And I am a very fresh student. I've recently joined my PhD, and my PhD topic will be on glaciology and remote sensing. And this training program helped me to learn a lot of things. I'm very thankful to Professor Helgi sir and Thora ma'am and other professors, guest lecturers, everyone for delivering such good lectures. And I hope that this type of programs should be held every year, and young researchers should be given opportunity to participate. And I'm thankful to all the participants here who have helped me out in solving all the problems. And yes, and also I'd like to pursue my research now. I'd like to start with this basic knowledge which I have gained here and start my research in glaciology. I hope I come up with good results and publish good papers. Thank you so much.
Anyone has to say something which is not very nice, something else.
Well, good afternoon, everyone. I'm Dia. For those of you who don't know, I think, if I'm not wrong, I'm one of the youngest students here. I'm still doing my undergraduation. Initially, when I found out about this training program from the IISc website, I was so excited and nervous at the same time. But then when I scrolled through and I read that it's only for MTech and PhD students, I was slightly disheartened, but nevertheless, I still did apply, and I really thank everyone, the board, for selecting me for this. I came here extremely perplexed about how much I'll be able to grasp, given the fact that I'm still at the undergraduate level. But I took on the challenge bold-faced, and I came here with nothing, but I have a lot to take away. My initial plan was to specialize in remote sensing and GIS later, but with this training program and the lectures from experts in this field, I have a new direction to what I want to do later in life, and I'm pretty sure it's going to be in glaciers and climate change and using remote sensing and GIS techniques to make further improvements in this field. So I would really like to thank all the speakers for their expert knowledge and their help, and also all my colleagues and friends for explaining little things to me, and basically it was a really nice time, and thank you.
Thank you. You are one of those who were undergraduate students which we selected. There were total 4 we selected, and 2 of them joined. With the idea is catch them young, so that when you complete your B, you choose to take glaciology as a career. So we have selected some bright student from undergraduate level. So you are one of them, and there's another one sitting there. 2 decided to come, 2 could not come. Anyone else? Last one. There's one more opportunity. That's all. Huh? Okay.
Thank you. I'm Akshay Kulkarni. I'm from Pune. We are from Pune, 3 people here, and we have completed our masters, just awaiting for results. We heard about something about induction, like magnetic induction. We heard those things. That is something that induced a magnetic field, and I was thinking, if we are in with good peoples, then the good things also will be implemented or inducted in our minds. Like these are the things that I have thought, and यहाँ के मुझे यहाँ ऐसे लग रहा है, like it's something induced in our minds, like the physics law is can be applicable in real life as well. So it's really good. Thank you.
I don't need that mic now, switch it off. So, because it's nice. That is why, you know, I normally very nervous to ask students to talk because they always say some nice thing. So that, with that idea, I have given you feedback form and option to remain anonymous. So anything different than what you have already said, if you want to say, which you are free to say. So there is no problem. I hope you will use that platform. It will help us to improve. So with this word, before I give formal vote of thanks, which is at the end, before that, let us start distributing the certificates. And I will announce the name of student, and then he can come and take a pause for a minute so that photographs can be taken at that time. So don't run in hurry back. Take a 1 minute pause. So first, may I request Professor Jason Nivasan, Professor Helgi, and Major. Yeah, it's a good idea to come here, and Akshay R. Kulkarni. A. It starts from A. Okay. Alok Tiwari. Alok Kumar Pandey. Anita Chandrasekharan. Ankur Dikshit. Archana Pradeep. Arvind Pandey. Asim Sattar. Bashir Ahmad Sheikh. Gitanjali Deshpande. From Colombo, yeah. Mohammuddin Diwan. Dia Sunil Kumbat. Dr. Archana Sarkar. Dr. S. Rajashekara. Har Amit Singh Sandhu. Harika Munakpatti. Kaushika GS. Krishna Pada Sarkar. Kirti Mishra. Litan Kumar Mohanty. Mahesh Bade. Andhra University. Muhammad Ramiz is from Jamia Millia Islamia University. Muhammad Yusuf Radar, Pondicherry. Nandita HS. She is a Bangalorean. So. Nivedita Khandegar. Smita Parith. Varsha Patil. Piyush Garg. Pooja Mishra. Pratik Verma. Ravikant Dubey. Reshma Kumari. Rohit Mangala. Rosemary Noble. Ruchika Bajpayee. Sai Arun Dharmik Bhoga. Santosh Chaudhary. Saili Kulkarni. Shakuntala VM. Gulbarga. Shashank Bhushan. Smriti Ranjan Patra. Yeah, biggest. So many applications, only 30% I gave admission, but still very large. Suranjana Baswati Bora. Tanuka Banerjee. Tashing Tashi. Sorry, I have not pronounced properly, but Tashing. Eluka Ramesh. Eluka Rakesh, sorry. Thank you very much. If someone is missing, he can meet me later on. I don't know. This is now, I already thanked people who have significantly contributed. Also, there is more significant contribution made by numerous people who are working behind the scene here. And I must admit that last 4 years we are organizing this course, but this is the easiest course to organize for me. Because our team has really become now very efficient, and I don't have to do much, just to announce the schedule and then just get approval from Helgi, then everything team puts at the place. So my special thanks. Some of them not here, particularly Nagraj is here, no? And Mamta from office, they have significantly helped us in organizing this course. In addition to two are sitting in front of you. One is Nagashri, she does all work, and Inakshi, also very managing all issues related to this training very efficiently. Thanks a lot. And some of the students you made, they are sitting at back, but they help me because they act as a guinea pigs for me to do the exercises. So, so that just to find out, because if they can finish in 1 hour this exercise, then I presume you can finish in 2 hours, because after working 2 years, they can take 1 hour you may took. So try to change, add something more to it so that it becomes very efficient. So it was a very wonderful journey for me, and I hope it is for you. So with this thing, I would like to thank all of you for coming here, particularly students. Yeah, that's right. So we are going to have group photograph. First group photograph is here. So what I will do is I will request all students to come so that you can stand behind, and we can have one photograph here, and another group photograph we can have up, so that both are there. So I invite all of you to come here so that we can have one photograph.